So here we have the function 8 minus the square root of 4 minus x squared minus y squared. Our first task is going to be finding the domain of this function. As the function is a square root, we can know what is inside the term cannot be negative. So thus 4 minus x squared minus y squared must be greater than or equal to 0. So rearranging that equation, that gives us x squared plus y squared is less than or equal to 4. That is our domain. To get our range, we plug in the absolute max and the absolute minimum x squared plus y squared can be, which is 4 and 0. Plugging in the maximum, 4, that gives us that our z value would equal 8. Plugging in the minimum would give us that our, which would be 0, would give us z equals 6. So now that we know that, we're going to plug in our fixed z values for them, 6, 6.5, 7.5, and 8. So for 6, you rearrange that equation, and you get that 0 equals x squared plus y squared. We know that that is a circle with radius 0. So doing the same thing for 6.5, that gives us that it's a circle with a square root of 1.75. We do the same thing for 7.5, and we do the same thing for 8. So now that we know with respect to the x and y plane, this is an increasing circle until it hits point 8. Well, the point 8. So next, we're going to vary the x term. So plugging in 0, that gives us 8 minus the square root of 4 minus y squared. Now, doing the similar thing we did in this first problem, this tells us that this is some kind of semicircle. Now, as we get increasing points in absolute value, the radius of the circle decreases. We do the same thing for the fixed y term, and we get that this is a semicircle with respect to x. So as we plug in more and more terms, the radius of the semicircle gets smaller. So plugging in all three graphs, this tells us that this is some kind of inverted dome with a fixed top at 8 and a bottom at 6.